that usually happens. They can just join back in.
Oh, okay. So the central angle is 120 degrees. So you're going to do 120 over 360 is equal to, do you know what the arc length is?
The arc length is 18.
I'm sorry, say that one more time.
Ricardo, can you stop scratching or whatever you're doing, or mute yourself, please? Anyways,
Yeah, scratching the keyboard.
Anyways, it says 18 is 18 is the circumference. So
let's replace the word circumference with 18 then. What about arc length? Do we know what that is?
No.
Is that what we're trying to find?
Yes.
So let's call it something. Let's call it what? Give it a letter.
Greek letter or Roman letter?
Whatever you'd like.
Okay, we can call it C.
C. Okay. So let's call it C. Okay, and we're going to try to find out what that arc length C is. Okay. So we're just going to cross multiply. So if you cross multiply, Ty, right?
Mm-hmm.
We're going to end up with C is equal to 18 times 120 over 360.
Yep.
And then Ty, tell us what that is, okay?
Yep. Okay. 18 times 120 divided by 360. 6.
That's equal to 6. That's it. Okay.
Mm-hmm.
Let's take a look at the next one. All right. So in this case, can you scroll up a little bit?
Oh yes. Okay. A circle has the radius of 3, and arc in the circle has a central angle of 20 degrees. What is the length of the arc? Either enter an exact answer in terms of pi or use 3.14.
Okay. So in this case, you're now given the radius is 3, and you know the central angle, right? And again, don't do anything. I'm just going to do I'm going to present mine. You don't need to press anything.
Okay.
Okay. If you look at this, okay, the diagram gave us, again, this was 20 degrees, this is 3, and we needed to find out what that measure was, okay? So wait a minute. The formula I gave you a moment ago, it was theta over 360, which is equal to arc length
over circumference.
Over the circumference, right?
Mm-hmm.
Okay, so what is the circumference formula, by the way?
Circumference formula is it would be arc length over circumference.
2 pi times how much?
2 pi times is it is it 3 in this case?
It is. That's right. It's 2 pi times r. So I'm just speaking in general here, right? So the formula, okay, for circumference is 2 pi r. So now let's take a look at this, okay? Do we know what do we know in this in this equation here? Do we know what theta is?
Theta is, let me see. No.
We actually do. Theta is
20, right?
That's right. Theta is 20. Theta is 20 degrees. So this angle in here, okay, is 20 degrees. So therefore 20 over 360 is equal to, do we know what the length of the arc is?
The length of the arc is 3.
No, that's the length of the radius.
Oh, the length, no, so the length is, wait, no, we don't.
We don't know the length of the arc. So because we don't know what the length of the arc is, what give it a letter.
W.
W, great. So we're going to replace the word arc with the letter
W.
That's it. And then the circumference here, I have 2 pi times, what's the length of the radius?
3.
That's it. Beautiful. All right, so from here, okay, we're going to solve for what W is, right? So we're going to solve for what W is. So again, don't look at this and be intimidated by it, okay? We're just going to cross multiply just like we did before. If we do that, tell me, what do I get? I get 2 pi times 3 times how much?
Times 20.
Good. All divided by?
360.
Excellent. And I'm going to encourage you to leave your answer in terms of pi there, okay? So meaning,
Yep.
like, I don't want you to use 3.14. I want to encourage you to leave your answer in terms of that symbol, okay? So so can you tell me, is there a if you look at this, right? 2 times 3 times 20, what is that?
2 times 3 times 20, that is 120.
120. So I'm left with 120 pi over 360. And just to simplify this a little further, okay, what is 120 over 360? Is there a common factor between the two? Can I reduce that fraction?
You can turn it to 1/3.
I can turn it to 1/3. Beautifully, nicely done. So this is pi over 3. So W is equal to pi over 3. That is how you are going to get to your answer there.
Yep. Okay, pi over 3. All right, check. There we go.
Awesome. Let's take a look at the next one here. Here it says a circle has a circumference of 6 and an arc length of 1. A circumference of 6 and an arc length of 1. And what we need to do is we need to find out what is the angle of the arc in degrees. Okay? In other words, we're looking for, are we looking for an arc length, or are we looking for the central angle?
You're looking for the central angle.
Excellent. So we're looking for the central angle, and again, I'm going to present. Again, don't do anything. So we have the situation one more time. You have a circumference, C is equal to 6, and the arc length this time, which I'm going to call with the letter A, okay, is 1. One more time. Ty, what does A here represent again? Is that the central angle, or is that the arc length?
It's the arc length.
Excellent. All right, so we are going to find out what that central angle is, okay? Ty, can you help me with the setup again with that formula I gave you a moment ago?
Wait, arc length over circumference.
Excellent. So the arc length in this case is how much?
Arc length is, so it would be 1/6.
Excellent. So it's 1 over 6 is equal to, do we know what the central angle is?
No.
We don't. Okay, so what are we going to call that?
Well, it's called theta already, so we might as well.
Excellent. We called it theta already. Good catch there. Okay, divided by how much?
360.
Excellent. Solve for theta.
All right, so that'd be 60.
That would be 60. That's exactly it.
All right. Yeah.
Okay.
I tried another one earlier, but I got it wrong. So we got 3 out of 4. So.
Oh, okay. No problem. All right. So Ty, do you want to move on to the next one? Just quickly knock it out.
Yeah.
Yeah. Let's just knock it out. Okay. So the next one, let me see.
It's
here.
challenge problems arc length. Well, that's an article.
Yes. So the one following arc length is circles quiz 1.
Yep.
So let's do that.
Okay. Oh yeah, I have to share that one now. Yeah.
You have to what?
And now I have to share my screen with that one. Yeah.
Oh, okay.
Yeah. It only lets you share one window at a time. That's all.
Okay.
There we go.
That's a lot of stuff to load.
Yeah.
Okay, so it says here in the problem that you have a circle with a radius of 3. An arc in the circle has a central angle of 60. What is the arc? What is the length of the arc? Okay, so the central angle is 60 degrees and the radius is 3. Now we need to find out what is the length of the arc. Again, don't do anything. I'm just going to present my screen. Okay, here we are. So for this situation, Ty, what's the length of the radius one more time?
3.
It's 3. What is the central angle?
Central angle is 60.
Excellent. And we're asked to find out what is the length of the arc in this case, right? So I want to give you another, before we get to this, okay, we're just going to quickly figure out what this is, and I want to give you a formula, okay? And remember, the formula stemmed from this proportion that we've been using. Wasn't that right?
Yeah.
Okay. So I'm going to, before we go any further, okay, I want to show you that what we can do, okay, is we can cross multiply, okay, everything in terms of r and x, okay? And if I do that, I'll end up with x is equal to 2 pi r times theta all over 360, right?
Mm-hmm.
Ty, what is meant by the letter x one more time? Is that the arc length or is that the central angle?
It's the arc length.
That is the arc length. And theta one more time is the
central angle.
Excellent. Okay, so now if you look at this, I see here I have 2 and I have 360, right? Is there a common factor between these two?
Yeah, 2. It
is 2.
It'll just be pi r theta over 180.
That's it. I get pi r theta over 180. And if I take a look at this, okay, and I'm just going to do a little bit of rearranging, okay? This is going to be a formula that's going to come up over and over and over and over and over again. So it is a good idea just to keep that formula in mind, okay, as we go through the process. So right now, okay, let's just keep all the different letters straight. X is equal to, X is equal to what again? What is that physically? Is that the arc length, radius, or is that the central angle?
It's the arc length.
This is the arc length. R is the
radius.
Radius. And one more time, theta is the
Theta is central angle.
Central angle. And keep in mind, it's a central angle in degrees. Okay? This is the central angle in degrees. So, to answer this question, you're asked to find out what the arc length is, right? The stuff that I've highlighted there in pink. So, wait a minute. Isn't the stuff that I highlighted there in pink, isn't that really just x, right?
Yeah, but we need to find a value for it.
That's right. So, Ty, tell me, what are we going to substitute in for theta?
Theta will be 60.
Nicely done. Do we know what, oh, and it's divided by 180. Do we know what r is?
R is 3.
Nice. And Ty, does 60 go into 180?
Yes.
How many times?
1. Actually, no, wait, yeah. 60 over 180 goes 3 times, so it'll be 1 over 3.
That's right. Nicely done, Ty. Right? So it's pi over 3 times 3. And what is like, can I reduce that further?
You just turn it into pi.
It just turns into pi. Ty, you are definitely on a roll here. Okay. So what is meant by x is equal to pi? What does that mean?
That is the arc length.
Excellent. Nicely done. So again, we are going to pop that in.
All right, 4 more.
Okay. All righty.
All right.
So it says here in the figure below, BD and AC are diameters of P. What is the arc length of DC in degrees? What is the arc measure of angle DC in degrees? So just by inspection here, Ty, right?
Mhm.
They gave you a central angle over there, APB, right? Do you see that?
Yeah.
What is that? What is that measure?
19.
What is the measure of central angle DPC then?
19.
Excellent. What do we know about the arc measure and the central angle? Are they the same or are they different?
They are different.
They're actually the same. The arc measure in degrees is the same as the central angle itself. So it's like saying, what is the arc measure of arc AB in degrees? What is the arc measure of AB in degrees, Ty?
Would it be 19?
It would be 19. So wait a minute. You just told me a moment ago that DPC, angle DPC, right,
Yep.
is also equal to 19 because you recognize that as being vertical angles, don't you?
Yeah.
So therefore, what would have to be the arc of DC?
19.
It too must be 19. Amazing. Okay, so circle D is below. What is the arc measure of BC in degrees? We got to find out what is the arc measure of BC in degrees. What do you notice? What do you know about all central angles? What must they all add up to?
360.
They all must add up to 360. Ty, strategize with me. How do you then figure out what n is as a result?
You take 7n plus 12 plus 6n plus 13n minus 16 equals 360.
Excellent. Please take a moment and do the math for me and find out what n is. Once you find out what n is, do not enter the value for n as an answer here because they're not asking for what n is. They're asking for something else. So let me know when you have n solved, okay?
Okay. So it'll be 26n minus 4.
So 26n is equal to?
26n minus 4 equals, so 20, so that would be 360 minus 4. Wait, let me turn this on.
Plus 4.
360, yeah, right. 360 plus 4 divided by 26. 14.
14. So n is equal to 14. What are you asked to find in this problem?
The arc measure of BC in degrees.
BC. So what you're going to substitute 14 into where?
BDC. So
That's
6n.
right.
So
That's
multiply
right.
by 6.
That's right.
And it's 84.
That's it. Ty, you are so good with this.
Thank you. All right. In the figure below, AD and CE are diameters of circle P. And we got to find the arc measure of AB in degrees.
Okay. So these so you recognize that those are diameters, right?
Yeah.
And you are now asked to find out what arc AEB is. Now bear in mind, okay, that you're going all the way around. Okay, you're going all the way around. Okay, so it's not like just this, it's not the minor arc. It's not the small section of AB. It's going all the way around AB, right? So it's AEB. Ty, can you tell me what is angle APE equal to? Angle APE equal to?
There's no given value.
It doesn't give it to you. However, if you notice, line AD is a very special line. What kind of line is that?
No, it's not vertical angles. APD or APE.
APE. Yeah, I want to know what is APE.
It's not a right angle. It doesn't give us that's a right angle.
That's right. It's not a right angle.
Let's see here. Is it also equal to 93?
It's not equal to 93. I'll give you a hint, okay?
Oh,
Now,
yeah,
angle
oh,
8.
oh, it would be you subtracted from you subtract 93 from 180. So 180 minus.
Excellent. That's it. So those two angles, okay, they're otherwise known as linear pairs, right?
Yeah.
Okay, good. So what would that be?
87.
87. So angle APE is 87. Ty, tell me, what is angle CPD going to be? CPD. CPD.
That'll be also 87.
That will also be 87. All right. So you're asked to find out what is the arc measure in degrees of AEB. What would you have to do?
So you take 360
Uh-huh.
and subtract it from 38.
Subtract it from 38. What else do you subtract it from?
You also subtract it from 87.
You subtract it from, you subtract it by, rather. You subtract.
Yeah, but
You
you
subtract.
by.
Yeah, you subtract 360 by 38, and then you subtract again by 87,
87.
and then you subtract it again by what? How much?
93 and then 87 again.
Excellent. So do that.
All right, 360 minus 38. Wait, 38 minus 87 minus 93 minus 87.
Excellent.
That's 55.
That's it.
Okay.
No, 305.
Say that again. I'm sorry.
It's 305.
Oh, 305.
305.
Oh yeah, 305 because you subtract. Right. Yeah, thank you, Emmett.
You're
It's 305 because you have to subtract 360 from 55. That's my fault.
Right. Hey, Emmett. I didn't realize you were there.
Yeah, sorry, I slept in my alarm by a couple minutes.
No problem.
So I joined like 15 minutes late.
No problem. Yeah, if you get a chance, take a look at that enrichment problem I posted yesterday afternoon. If you haven't gotten a chance to take a look at that yet,
Right
after this, I'm gonna go over that with you guys. Okay.
Cool. Wait, are we gonna do radians and degrees tomorrow?
We're gonna do radians and degrees. Well, actually, we did the conversion yesterday.
Wait, we did that already? In con?
Yeah. Say that again. I'm sorry.
We did that like problem in con.
We did that. Well, I gave that formula to you guys yesterday, and we also went through that exercise.
Oh, I guess I don't remember doing it.
Okay.
Yeah, I mean, I definitely did it.
Okay. So this problem here says a circle has a circumference of 8. It has an arc of length 32/5. What is the central angle of the arc in degrees? Okay. So the 32/5. One more time. What does 32/5 mean in this problem?
32/5 is it is the arc length.
32/5. Read it one more time.
It's the circumference of 8, and I see. Isn't the wait.
I'm sorry.
So
Yes. You're right. I'm sorry. I was mistaken by looking at the diagram, and I didn't look at the words that are actually written there. You're right, Ty. Okay, so it is the circumference. I mean, it is the arc length. So I'm going to, or actually, do you know what to do?
I think so. Yeah, we take the value of we're supposed to find the central angle. So we take it'll be theta over 360 equals 8 over 32 over 5.
Equals the other way around. 32 over 5 divided by 8. Remember, because it's the arc length divided by the circumference, right?
Yeah.
Okay, so let me just do a really quick share screen. It should look something like this. So you should have something like this set up.
Yeah.
Okay. So again, don't be intimidated by this. Okay. Because it's nothing to feel intimidated about. You're just going to multiply both sides by that, right? By 360. And if you do that, right, you get theta is equal to 32 over 5 times 360 all over 8, right?
Mm-hmm.
And
okay. It's 288.
Say that again.
And theta equals 288.
Oh, you did it all in one step already. Yep. Nice. Theta is equal to 288. Okay. And I'm going to stop presenting. Look at that. That was it? That was the sixth one?
Yeah. The fifth one, yeah.
Okay. But was that it with the exercises? I think there's one last one, right?
Yeah, the radian and degrees.
Yeah, there was one more, radian and degree. Let's just quickly get that out of the way so that you'll be done with all the exercises this week, because we went over that yesterday. But
okay.
Okay.
Radian degrees. Here we go. Let me present. Yeah. It's loading.
Awesome. So Ty, before again, I'm going to let it load. Okay, I'm not going to give you the same like the same kind of presentation like I did yesterday with this, but instead I'm just going to give you a quick crash presentation of it. So the formula I want to bring across is, okay, so in the problems that we just went through, the last thing I shown you was this thing right here. It was x is equal to theta pi over 180 times r. Remember that?
Yep.
That was one of the last things that I had shown you. Okay, one of the last formulas that we had gone through. Okay, so I'm going to quickly tell you something right here. Okay, and that is this guy right here that I'm going to highlight. Okay, this in mathematics, okay, is what we call a radian measure. Okay, so this I'm going to say theta pi over 180. Okay, is equal to I'm gonna give it a letter. Let's call this thing let's call this thing like n or something. Okay, or actually here, yeah, let's call it n. So this, let's just be clear here. Theta, okay, is the central angle, right? Theta is the central angle, and it's the central angle in degrees.
Yeah.
How many degrees are there in a circle?
360.
360. N okay, which is what I'm calling theta pi over 180, okay, n, okay, is something known as, it's also the central angle. Okay, it is also the central angle, but this central angle is what we call a radian.
Okay.
Okay, and the central angle in terms of a radian actually came from the concept of, let's not describe the angle measure of a circle in terms of degrees, but rather in terms of the arc length of what we call a unit circle. Okay, and there's this concept here of what a unit circle is. Okay, is a circle with, Emma, do you remember?
Radii of 1.
Yeah. So it's a circle of radius of 1. Okay.
Okay.
And this concept of a radian measure, okay, it's just way more natural to think of an angle in terms of radians. Okay. And I'm just going to put another footnote here. So a radian measure is the arc length of a unit circle. So I was trying to explain this yesterday during office hours, that, you know, this is a way more natural way of thinking about angle measures rather than in degrees, because a degree measure is a man-made thing. So no matter where we are, you know, in the universe, okay, if there's another civilization somewhere out there, they are going to be talking about an angle measure in terms of the radian measure and not a degree measure, because a degree measure, 360 degrees, is a man-made thing. Anyway, that's very, very highly philosophical of us to think about that, but it is, you know, at its core, okay, what separates, you know, what's natural and what's not. Okay, so again, for that reason, mathematicians, when they talk about central angle, okay, they near 100% of the time will be referring to it in terms of the radian measure. Okay, so anyway, having said that, let's take a look at the example that they gave us, or that they want you to solve. I'm going to stop presenting and let's take a look at this now. So this question here, it says convert the angle theta, which is 8 pi over 9 radians, to degrees. Okay, so right now, the theta that they gave you, is that an angle that is in radian or degree? One more time, Ty.
That is in degrees.
That is in radian.
Yeah, it's in radian.
You want to convert that into degrees.
Yeah.
Okay. You want to convert that into degrees. So what are we going to do to accomplish this? Well, let's just go through it really quickly, right? So again, the conversion that I just gave you a moment ago, okay, is this formula that's boxed in right now. Okay. Or actually not the formula that's boxed in. It's this thing that's highlighted. So one more time, what's highlighted in green is the conversion from degrees to radians. Okay. So 8 pi over 9, okay, is that n, or is that theta?
8 pi is, that's 10.
8 pi, no. My question is, 8 pi over 9 is the number that's given, right? Is that the central? Is that n, or is that theta for this formula?
It's theta.
It actually is. It's n, because n. What does n represent again?
N represents the central angle as a radian.
As a radian measure, and 8 pi over 9 is a radian or a degree measure?
Radian measure.
It's a radian measure. That's right. It's a radian measure. So because it's a radian measure, 8 pi over 9 is really n in this case, okay? And we're looking for theta, which is in the formula. Is that degrees or is that a radian? Theta
Degrees.
in the formula here.
Theta is degrees.
Theta is degrees. So we're going to look for what theta is, okay? In this equation that we are setting up. Anytime you have the same things both on the left and right, okay, of the equal sign there, okay, what can we do with the pi there?
You cancel it out.
Cancel it out. So we get 8 over 9 is equal to theta over 180. And from here, we can then cross multiply, right?
Yep. So theta equals 180 times 8 over 9.
And what is that?
160.
Nice.
Let's see. Yep.
Okay. The next thing here says convert 290 degrees into radians. Okay, so let's do that really quickly. 290 degrees into radians. So right now, you're given 290 degrees. Is that, one more time, is that n or is that theta?
That is theta.
That is theta. Nice. And then the formula says n is equal to theta pi over 180, right?
Yeah.
Can you help me with the substitution?
Okay, so 290 pi over 180.
Right. So if I go in, is there a common factor between the numerator and denominator?
10.
There's a common factor of 10. So therefore, this is going to be 29 pi over 18. There's no other common factor. You can enter your answer in terms of pi, it said, right?
Yeah.
Okay, so I think that's as far as we can go.
Well, yeah, it's just express here exactly.
Oh, it says enter exactly, but does it say in terms of pi or no?
It doesn't say it, no. So it would be 5.06, I believe.
5.06?
Yep. Well, that's the answer I got when I got 29 pi over 18.
So you know what? Can you do me a favor? Let's just, here, you're going to enter that again. You're going to enter in 29 pi over 18. Actually, 29 pi over 18 would be the exact. And this 5.06, that is actually an approximation.
Ah.
So you're going to do that again. So you're going to click on to enter the formula one more time. All right, to enter the answer one more time.
Oh, wait. Oh, so you want me to, so 5.0614.
No. So you're not going to enter the decimal. You're going to enter it in as a fraction.
Okay,
Because no matter how many decimal places that you put in, it will still be an approximation. It would not be exact. So you're going to enter 29.
29 over 18 pi.
And then you're going to enter that fraction. Yes, there you go. And then you're going to press up.
Yeah.
Yeah, that works too. Yep.
All right. Convert the angle theta equals 29 pi over 15 radians to degrees.
All right. So in this case, 29 pi over 15, is that n or is that theta?
Theta.
That is, be careful, n. Is n radians or is n degrees?
And is, wait, we have to convert n radians to degrees. So this is
Yes.
n.
So in the formula that I gave you, right, n represents radians. So is 29 pi over 15 radians a measure in radians or is it a measure in degrees?
That's a measure in radians.
Yes, you got it. Okay, so because of that, you're gonna re-represent this. Okay, 29 pi over 15 is n, and you're solving for theta.
Mm-hmm.
We have pi on both sides, don't we?
Yep.
So because
So
we have
cancel.
pi on both sides, we can eliminate. We got 29 over 15 is equal to theta over 180. We can cross multiply. So Ty, tell me, what do you end up with as a result?
So that would equal 348.
348. Nicely done.
All right. Last one. Convert the angle theta equals 35 degrees to radians.
35 degrees into radians. So what do we do in this case? Is 35 degrees, is that n or is that theta from the formula?
That is theta.
That is theta in this case. So we're going to go over here. So we're going to say 35 times pi over 180, and that is equal to n.
Mm-hmm.
Is there something that we can maybe perhaps like reduce between 35 and 180? Is there a common factor between 35 and 180?
5.
Yes. So that's 7 pi over 36.
Mm-hmm. All right. Oh, that's the answer.
That's it. All right. So everyone else, thank you for being so patient there while Ty and we were finishing up that problem. I do want to go over with you guys that enrichment problem. Now that you guys had some opportunities to think about it, did anyone come up with a strategy to find the answer to that enrichment problem?
I have
didn't
no
get a
clue.
chance to look at it yet.
You had
I
no
don't
clue?
even know how you find the height of that triangle.
Okay, so you know what? Give me a second here. I'm going to stop recording.